guys cut this out yesterday. You put it on a separate sheet of paper. You taped it together, okay? But the most important things are 3, 4, and 5, okay? How does the area of one trapezoid compare to the area of a parallelogram? The trapezoid is half the area of a parallelogram, parallelogram. Everybody get that, or they put it the opposite way? The parallelogram is twice as big as the trapezoid. Okay. We're going to write the expression. Now, I had a lot of people struggle with this. What is the base of this parallelogram right here?
B1 plus B2.
Base 1 plus base 2. I had people put times. I had people put all kinds of crazy stuff. Okay. The height is still height, correct?
Yeah.
That's the formula for this area. The only thing different with a trapezoid is we know it's half as big. So we are going to divide it by 2. Okay, let's look at the other side with a kite. Okay, we have diagonal 2, diagonal 1, and we're cutting it. This is still diagonal 1 on the top, but this is not diagonal 2. It's what? Half of diagonal 2, right? So if I'm looking at this triangle, the base is D1. Shh. Anybody have a question?
I think you do.
No, I don't have a question.
Okay. We are recording currently. We are recording currently. You need to be paying attention. And the height is 1/2 D2. Okay, so if we wanted to write an expression or the formula for how to find this specific rectangle, we would say D1 times 1/2 D2. That would be the area of this rectangle. Is this rectangle and kite the exact same area? Yeah. 1/2 D1 times D2 would be that area. I just switched it up a little bit so the D1 and D2 are together. And those are diagonals. Diagonal 1, diagonal 2 times 1. All right, guys, the important stuff. We went over this yesterday some. Let's look at today's. Okay. So we have area of a regular polygon. We're going to go over some of this vocab on the top in order to help us figure this out on the bottom. Okay. The center of a regular polygon is the center of its circumscribed circle. Okay? The center of a regular polygon. So we've got the center of this polygon. We can think of a circle being around the outside. So you guys know what I talk about when I talk about radius or central angle and stuff like that. Okay? The radius of a regular polygon is the radius of the circumscribed circle. The distance from the center to any side of a regular polygon is called an apothem. Okay, we're going to talk more about that. A central angle of a regular polygon is an angle whose vertex is the center and whose sides contain 2 consecutive vertices of the polygon. Area of an equilateral triangle, we may use this. Area equals 1/4 square root 3 times the side length squared. An area of a regular polygon. The area of a regular nonagon with side length s is half the product of the apothem and the perimeter. So area equals 1/2 a times perimeter, or 1/2 area times the number of sides. Okay. I've got 4 examples here. And then on the back is going to be your 6 problems for homework. Okay. So let's go through this carefully. This is a pentagon, meaning it has 5 sides. We've got an apothem, so right here is 10 feet. Okay. So what we're going to look at, guys, is it is made into different equilateral is five-sided, it has 5 equilateral triangles. You guys see that? Where 10 is the height of the triangles. Okay. The problem with this one is we don't know the length of the side. Okay, because we could find the area of each of these triangles, times it by 5, and we'd be done. But we need to find the length of that side. So we're going to talk about central angles. Okay, so that's what we're doing right now, is a central angle. Okay, so we agree that a circle's angle is 360, right? So since this has 5 sides, we're just going to go 360 divided by 5. And we get 72. Okay, that's this whole angle right here. I want to look at half of it because then I have a right triangle. I can do some stuff with it. So I know this length is 10. I want to know what that angle is right there. So I'm just going to go 72 divided by 2. And I'm going to get 36 degrees. That's this right here. It's 36 degrees. Okay. Now, I want to know what this length on the bottom is. Does anybody remember what we would use if we have one side of a right triangle and we know the degrees of one of the angles? Yes. It's actually tangent, but good, it's trig. Okay? So this is opposite and adjacent, so we're going to use tangent. So tangent of 36 equals opposite x over adjacent 10. Do we agree that what I'm finding is this length right here? What am I going to have to do to that length to find the length of one side?
Double it.
Okay. So I'm going to put in my calculator 10 tan 36 equals x and find that x equals. So in your calculator, 10 tangent 36 gives us approximately 7.3. I'm going to round it. Okay, so now I'm going to take 7.3 and times it by 2 to find the side length. 7.3 times 2, giving me 14.6 feet. Okay, I'm not even close to being done yet. That's just the side. So I need to find the area of a triangle. What's the area of a triangle, guys? Do you have a question, Ryan? Yes. Shh.
What did you do?
Why did I double it? Because I divided my equilateral triangle in half so that it was a right triangle. And so I only found the x, what x equals 7.3, is only this half. So I need the whole length right here. 7.3, giving me 14.6. Okay, now I'm going to use the area of a triangle, which is, who knows what the area of a triangle is? Come on, guys.
Base times height.
Good. 1/2. My base is 14.6. Times my height is 10. Okay. So one triangle is 73 feet. How many triangles do I have? 5. So then I'm going to take 73 and times it by 5. 365 feet squared is my final answer. Okay. So, we're going to do another one, but it's different. So this one, I had the apothem. The apothem is always from the center to the side. Not the center to a quarter, but the center to a side. So now I'm going to look at a hexagon. I'm given the radius is 7. So when it says radius, it's from the center to a corner, as if a circle is surrounding it. You should be writing this down, guys, because your homework's just like this. You're going to need this information. Okay, so I have a hexagon because I have 6 sides. So I know I'm going to have 6 triangles, right? Okay. It's an equilateral triangle, so if the radius is 7, I know also the bottom is 7. What don't I know, though? I do not know the height. Okay. So again, I'm going to have to divide it in half. So 7, so I'm going to do 7 divided by 2 gives me this area, this length right here at 3.5. You guys have to tell me when you're confused or if you can't see. Yes? Why did I divide it by 2? Because I want to look at this right triangle because I'm trying to find this height right here. But I do know this length right here is 7, right? So do I have to use trig? I have 2 sides of a right triangle. What can I use? Pythagorean theorem. H squared plus 3.5 squared equals 7 squared. So h squared plus 12.25 equals 49. And no one can see this, and you guys don't tell me. There we go. So then we're going to subtract, and we get h squared equals 3.67. No, that's 36.7. Wait, hold on. It's 36 point, no, it's 12.25. 36.75. And then I'm going to square root it. So h equals, or it's approximately, 6.06. That's my height. Okay. Now I'm going to do the area of a triangle. 1/2. Yes?
How did you get the other side at the bottom?
It's an equilateral triangle, which means all 3 sides are the same. 1/2 the base 7 times the height 6.06 means one triangle equals 21.21. And how many triangles are there? So I get I did 7 times 6.06 divided by 2, and that was 21.21. I'm timesing it by 6, and I get 127.26 centimeters squared is my final answer. 7 times 6.06 divided by 2 is 21.21. And then I times that by 6 because there are 6 triangles. Yep. Okay. Let's look at the next one. We've got an octagon. It has an apothem of 8 feet. That means straight up and down, this is 8. And it's an octagon, we've got 8 triangles. What we don't have is the length of the side. Okay? They are all equilateral, but this is the height right in the middle. So we don't have any of the sides. So, we're setting up our triangle. First, I have to find my central angle. So I go 360 divided by 8, and I get 45 degrees. But I don't want this whole thing, I want half of it. So I divide it by 2 and get 22.5. Okay, my apothem is 8. I need to find this length here at the bottom. So again, this is my adjacent, this is my opposite, so I'm going to use tangent. Tangent of 22.5 equals opposite x over adjacent 8. I'm going to multiply the 8 by both sides. I'm cross multiplying. I put it in my calculator and I get x is approximately 3.31. But that's just this part right here, right? I want the whole side. So what am I going to do? Times it by 2. And I get the side length is 6.63. Okay. Now I'm going to find the area of one triangle. So that's 1/2 the base, 6.63, times the apothem, 8. And that gives me, what? 6.63 times 8 divided by 2 gives me 26.52. One triangle. Okay, but now I want all of the triangles, so I'm going to times it by 212.16 feet squared. It is a lot of work. It is a lot of work. Okay, so let's think. When we have the apothem, we're going to have to use trig. When we have the radius, we can go ahead and use Pythagorean theorem. But as we're going through the next one, let's try writing steps down so that you don't get lost in the process. Okay? So I'm going to write them as I go. Okay. So we're going to look at the last one. I'm going to move it over. We've got a hexagon with a side length of 4 and a radius of 4. So we know this is 4. We know the bottom is 4. What we don't know is the apothem, the height of the triangle. Okay? So the first thing we do is set up our right triangle. If we have the radius, use Pythagorean theorem. Okay. If we have the apothem, use trig. Okay, step 1. So we're going to make our triangle. We know one side length is 2, right, because I split it in half. The other side is 4. So 2 squared plus x, or height, squared equals 4 squared. So 4 plus height squared equals 16. So height squared equals 12. So height, because I'm square rooting it, is approximately 3.46. Yes. Okay. If we have the apothem, use trig. If we have the radius, use Pythagorean theorem to find the height. Okay. Step 2. find the area of one triangle. Okay, so that means we're going to do, yes, ma'am. You do. Good. We're going to, no, height is right here. When we're trying to find the side length, like in the past one, we do times it by 2. Find height or side length. You're confused why we're not times 8 by 2? Yeah. Okay. Because we found this right here. So we don't need 2 of them. If we found this part on the bottom, we would. Okay? So then we're going to go 1/2 the height, 3.46, times the base, which is 4. And we get one triangle is 6.92. One triangle. How many triangles are there in a hexagon? 6. So 6.92 times 6, giving us 41.52 feet squared. Okay? All right. So you're going to use this information in order to do the back. Remember, if you have the apothem, you're going to use this side of your paper as examples. If you have the radius, you're going to use this side of your paper for the example. Yes? Half of 4 is 2. You're always going to do half because you're looking at, you're cutting the equilateral triangle into 2 parts. So, for example, if ever I have an equilateral triangle and I want to use right triangle, I have to cut it right here to make it 90 degrees, which means this bottom part here has to be cut in half. If this whole thing is 8, this part will be 4. Oh. Okay. All right. So we're looking at these 6 problems. I'm giving you a lot of time in class to work on them. You're going to find the area of the regular polygons. Look, this one's really nice. It gives you the apothem and the side. Okay? There's so little work you've got to do for this one because you can figure out right away one area of one triangle, right? You have the height and the base. That's for 1, 2, and 3. Okay? 4 is a little complicated because it's just the square root of 3. Shouldn't make a big difference. It's 5 and 6. Where 5 I gave you just the apothem, 6 I gave you just the radius. So these are the ones that are going to take longer. Remember, the first 4 are pretty much done for you. You're literally finding the area of one triangle, timesing it by how many sides there are. Questions? Okay. You have the rest of the hour to work on that then?